Hello friends, in this question we are asked to find the differential equation corresponding to an LTI system whose impulse response is given as h of t equals e power minus mod of t. Okay, so how to proceed? So h of t equals e power minus mod of t. Okay, this can be written as h of t equals e power t for t minus infinity to 0. Okay, why? Because this e power minus mod of t for t less than 0, this t is going to be negative, but this mod has to ensure that it should be positive. So an extra minus sign will come, so it will become e power minus of minus t, which will be e power t. Okay, so this is e power t. Now for t more than equal to 0, it's going to be e power t. Okay, so e power minus t. So we have defined our function fully now. Okay, so this is how this impulse response is defined for t, various ranges of t. Okay, now we know that this is the impulse response h of t. Now input is x of t and output is y of t. This is in time domain. Okay, in frequency domain it is going to be x of s, and the transfer function is h of s, and the output is y of s. So this is related by this equation, h of s is equal to y of s over x of s. Okay, these will be useful for us. Okay, that's why these are being defined. Okay, so now let us proceed and solve this question. Now h of t equals e power minus mod of t. Okay, now what we will do is we will calculate its Laplace. Okay, so why we calculating Laplace? Because it will be easy for us to uh, use this relation h of s is equal to y of s over x of s. Okay, so this is our target. So to achieve that, first we need to calculate the Laplace of the impulse response. Okay, so Laplace of h of t is equal to, so this is the definition of Laplace. Okay, so it will be minus infinity to infinity. Okay, minus infinity to infinity h of t e power minus st dt. Okay, now h of t, as already we know, is e power t for t minus infinity to 0 and e power minus t from 0 to infinity. So we'll put that here. Okay, so we can break this limit. So from minus infinity to 0, it is going to be e power t e power minus st dt, and from 0 to infinity it's going to be e power minus t e power minus st dt. Okay, now you can observe that this is simply the Laplace of e power minus t u of t. Okay, if you write this in the expression, this will be written like this. Okay, so its integration already we know, because we know its Laplace. Its Laplace is 1 over s plus 1. Okay, so this term Laplace is already known to us now. Okay, so this term Laplace is already known to us, this term. Okay, we are only left with this term. Okay, so what we do is we now apply, we first uh, uh, take both the exponentials together. Okay, and after that what we do is we use this property e power at dt. Integration of that is e power at over a, where a here is 1 minus s. Okay, so when you use that, you get this, and these are the limits we need to put. Okay, when you put this limit, this minus infinity will give you 0, and this 0 will give you e power 0, which will be 1. So you are left with 1 over 1 minus s. Okay, and this 1 over 1 plus s is already there, so we'll take LCM and we get our h of s as 2 over 1 minus s square. Okay, so the final result is h of s is equal to 2 over 1 minus s square. So now we know our h of s. What we do is, as I already told you, h of s is equal to y of s over x of s. So we now use this relation. Okay, so let us do it. So now this 2 over 1 minus s square, which was calculated earlier, is equal to y of s over x of s. Now what we do is we cross multiply here. Okay, so what we get is 2x of s is equal to y into 1 minus s square, or 2x of s is equal to ys minus s square y of s. Okay, so now what we do is, see, we need the solution in time domain, so we'll revert back to time domain. Okay, that can be done by taking Laplace inverse, so that Laplace inverse will be taken both right and left hand side. Okay, so this Laplace inverse of x of s is x of t. Okay, and Laplace inverse of y of s is y of t, and here this Laplace inverse of s square y of s is equal to, now this is the differentiation property. Okay, s y of s is y dot of t. Okay, the Laplace inverse. Okay, so Laplace inverse of s square y of s is double differentiation, which is y double dot of t. Okay, so which is written here, now what we do is we take all the y terms to one side and x terms to other side, so we get minus y double dot of t plus y of t is equal to x of t. Okay, so from here you can see A is the correct answer for this question. Okay, so this is how you can proceed for the this kinds of problem. Okay, first you take the Laplace transform and again revert back to the time domain. Okay, so thanks for watching.